This set of notes is on driving forces in Gibbs free energy, and the surrounding theme of this set is whether or not reactions will occur spontaneously or not. So how can we tell if a reaction will occur spontaneously? Well, we can look at the change in heat content, or the enthalpy. So lazy products want to have less energy, which is why things existing at a lower energy level are favored. Most of the time when we talk about energy reactions happening spontaneously, if we're just looking at the energy, something that's exothermic with a lot of heat released will be the most spontaneous, because the products are going to be favored because they will be existing at a lower energy level than those reactants. But some endothermic processes can occur spontaneously. So for example, ice, you have to add energy to ice to melt it, and this just happens. It's not like we sit there and use a blow dryer to melt ice. Ice will just melt on its own. And the reason why that happens is the second driving force, which is entropy change. So hopefully you remember entropy from our sodium thiosulfate lab, where entropy is the measure of disorder. So again, don't confuse enthalpy, which is heat content, and entropy. So entropy is the randomness of particles. So remember, when we increase the temperature on something, that means that those particles are going to start moving faster, which means that those particles have more randomness. Thus my entropy has increased. So because we increase the entropy when we melt ice, it is spontaneous. So in nature likes to become more disordered. It is easier, it takes less energy to be disordered. Think about it like this. It takes less energy to clean your room than it does to clean your room. So it takes less energy to have a disordered room. Our symbol for entropy is S, and so if we're saying that there's a positive change in entropy, then that's a plus change in S. A negative change in entropy is a minus change in S. So we want a plus change in S if our situation is becoming more disordered. This wants to happen naturally. To become more ordered takes energy, and that's a negative change in S. So the world tends towards being lazy and disordered. So less energy and less heat and more disordered. So ice molecules, when we're talking about in the solid form versus the liquid form, again, liquid molecules are more ordered and more random, and the entropy will be increasing, and it's favored. So the entropy, again, is denoted with a letter S, capital S. So the ordered world has a low entropy, and the random or disordered world has a high entropy. So an increase in the randomness is positive, it wants to happen, and a decrease in the randomness is negative. It does not want to happen. So an increase in entropy is good, that wants to happen in nature. A decrease in entropy is not good. Becoming more ordered is not favored in nature. It takes too much energy to be ordered. So the two factors that will affect whether a reaction will happen are the enthalpy, so are you going towards a lower enthalpy or a lower energy, and towards a higher entropy or a higher randomness. So those are the two factors that we'll be looking at. So again, entropy is the measure of degree of randomness of particles, such as molecules in a system. So if I'm looking at this chemical formula, we can actually identify the entropy change. I cannot identify the enthalpy change because I am not given a thermochemical equation. I'm not given the change in kilojoules per mole on either the reactants or the products side, but I do know the number of moles present on both sides. And so because I go from 2 moles of reactants, to 7 moles of product, I can say that my entropy is increasing. So my change in S is positive, and my situation here becomes more random. And that's a good thing. In nature, things want to tend towards randomness. Putting them together is what we call free energy. So the heat content and the randomness of particles affect whether or not the reaction will be spontaneous. Free energy, or capital letter G, is the combined enthalpy-entropy function. And we measure it with the change of G is equal to the change in H minus temperature times delta S. So a lot of people will ask what that T is, and that's temperature. So you got to know the temperature, and then you'll know the entropy and the enthalpy. So when we're all said and done, the only thing that we're going to actually be able to measure and the only change that can be measured is the change in G. So that's what we will go off of. So putting it together, again, nature drives reactions towards low enthalpy and high entropy. So in order for something to occur spontaneously, the delta G has to be a negative value. So if I've got an exothermic reaction and something that's becoming more disordered, G will always be negative. And this, because G is always negative, will always occur spontaneously. And if something is exothermic but becoming more ordered, delta G is negative at a low temperature, so it will occur spontaneously only at a low temperature. Endothermic, if I'm gaining energy and I'm becoming more disordered, G is negative at a high temperature, so it will only occur spontaneously at a high temperature. And then if I'm endothermic and becoming more ordered, G is positive, and it will never occur spontaneously. So you might want to pause the video and copy these things down and identify when something will occur spontaneously versus when it won't. So again, just to review, if it's exothermic and becoming more disordered, it's almost like saying that these two things are happy. So this is happy, this is happy, this is always happy. So this is always going to occur. Exothermic is happy, but becoming more ordered is unhappy. So it's only going to happen, the reaction will only occur spontaneously at low temperatures. This is unhappy because it takes energy, but it's becoming more disordered, so this is happy, and it will be occurring spontaneously only at high temperatures. Both of these things do not want to happen, and so thus it will always be positive and will never occur spontaneously. So another way to decide the reaction if it will occur spontaneously is looking at activation energy. So if we look at this, if we can decide whether or not it's endo or exothermic. So first of all, because that number is on a product's side, I know that it's exothermic. And so our change in G, thus, could be predicted as a negative 237.1. This isn't the best question because it doesn't actually give us our temperature that we're existing at, but we can look here, it is becoming more ordered, and so it's a little bit difficult in terms of if we're identifying if we're either at a high or low temperature. So don't worry, I would never ask you a question like that, but if I know that G is negative, then I know that it's always going to occur, it's going to occur spontaneously. So this would be spontaneous simply based on the fact that G is a negative value. So now our practice problems for Gibbs free energy is, don't forget you have an equation up here, change in enthalpy, temperature in Kelvin, and change in S is the entropy. So what I recommend is that you write the grid in from our notes, fill in the grid, and then answer the questions, and we will check this on Friday.